Okay, so 2 years ago, I gave a presentation at CWEMF about how the lower San Joaquin River had transitioned from being a gaining river, receiving water from groundwater, into a losing river, with seepage losses through its banks and/or bed to groundwater. And now I'm giving an update on changes in the river over the last 2 years. So the area that I'm talking about is from the San Joaquin River near Stevenson. At the south end is the upstream end of the reach, and then down to Vernalis, just upstream of where the river enters the delta. And you can calculate the ungauged inflows, the interactions with groundwater, by looking at the difference between the outflow from the river at Vernalis and then subtracting the sum of all the inflows from the gauges and all the tributaries flowing in. And so the area for which I'm doing this analysis, you see in pink, runs from Stevenson down to Vernalis. It also includes the east side tributaries downstream of their gauges. And in this talk, I'll be talking about 4 gauges in particular, Stevenson and Vernalis at the upstream and downstream ends, Crow's Landing in the middle, and the Stanislaus River at Ripon. So this is the average ungauged inflows for each year. And the San Joaquin River has been in about a 20-year decline. 20 years ago, it was receiving over 500 cubic feet per second of water coming in from groundwater, other ungauged sources like ag drains. But that's been going down for at about 40 to 50 CFS per year until about 2014, when it transitioned to being a net losing river. Now, in very high flow years like 2011 and 2017, there's a lot of water loss, and that's to be expected as the high level in the river means water flows by gravity to replenish the local groundwater. And you see there's a rebound in 2012 and also this year, where there's only about 110 CFS being lost from the river on average through the just finished wet season. But to really see more about where water is being lost, you have to look at salt. And so I split the reach into 2 segments, from Stevenson to Crow's Landing and from Crow's Landing to Vernalis. And the upper reach from Stevenson to Crow's Landing, on average this winter, was gaining 160 cubic feet per second. And as expected, was also gaining salt, about 245 tons per day. The lower reach from Crow's Landing to Vernalis was losing on average of 272 cubic feet per second. It's a lot of water, but still gaining 279 tons per day of salt. So how does a river simultaneously lose water and gain salt? Well, mathematically, the way it happens is you have a small quantity of high saline groundwater inflows and a larger quantity of low salinity seepage loss. Now, in the San Joaquin Valley, the low salinity water comes from the east side tributaries coming down from the Sierras. And between Crow's Landing and Vernalis, that would be the Tuolumne and Stanislaus rivers. So are they losing water? So to reconcile the flow loss and salt gain, an example would have an average of about 96 CFS of groundwater inflow at an electrical conductivity of 2,000 microsiemens per centimeter, combined with a loss of 368 cubic feet per second on average from the Stanislaus River at an EC of 67. And the math works better for the Stanislaus River than for the Tuolumne River, because the Tuolumne River, although it has a low EC, it's about 40% higher on average than the EC in the Stanislaus River. So more evidence that would tend to implicate the Stanislaus River comes from the flow pulses that were released down the Stanislaus River this winter. Here in this graph, the colored bands show the inputs to the reach from Crow's Landing to Vernalis. And the major ones from bottom to top are the San Joaquin River proper, upstream of Crow's Landing, then the Tuolumne River, then on top in orange is the Stanislaus River. And you see